Okay, so here in section 1.4, we're looking in more detail at angles. So if you've been tracking with where chapter 1 is going, we started with points, lines, and planes. Then we built in to this idea of distance between 2 points. So we're measuring segment length there. Now we want to start looking at angles is another big part of geometry, and this is where we have two rays that are going to connect at a common endpoint. And when that happens, we have this ray AB that moves out in this direction and ray AC that moves in this direction. What happens is an angle is formed. Okay, so we want to talk about three different types of basic types of angles here. You have an acute angle, which is what we're looking at here. With angle 1, we would call that an acute angle because it's less than 90 degrees. A right angle is 90 degrees, and that's going to look like this. And what we'll do to make it very clear if something's 90 degrees, we'll put a little box in the corner. Okay, now if we have an angle that is bigger than 90 degrees, suppose it looks something like this, you'll kind of see a wide expression there. That's called an obtuse angle. Okay, so we want to be able to identify an obtuse angle that's greater than 90 but less than 180. So 180 degrees would be two 90-degree angles, so that would basically go a ray in this direction and a ray in this direction, and that would be 180 degrees. We call that a straight angle. But we want to really just focus in on acute angles that are less than 90 degrees, obtuse angles, and then right angles specifically. So like I said, just due to availability, we won't follow any directions that say to use a protractor, but let's just make sure that we can simply classify the angles as acute, obtuse, or right. So the first thing we want to do is talk about how we name angles. So we look at where angle 4 lives. He's in here. And what would be the vertex? The vertex of an angle is always just a point. So the vertex of angle 4 is point B. Okay? Now, the sides of angle BDC. Let's take a look at where angle BDC lives. And we'll highlight that. So BDC means that we're going to go from B to D to C, and we're going to observe the angle that's formed there. The angle that's formed there is really angle 2, but we could also call that angle BDC, or we could call it angle CDB. We can name it either way. So angle 2 is this angle that's in there, but they're asking us for the sides. So the sides are going to be the two rays that are formed here. So we have ray DB, and remember, we have to be specific. Mr. Blaylock broke this down for us. We have to show, if it's a ray, we have to make sure that there's no arrow above the D. The arrow belongs above the B. And the other ray is ray DC. And again, since D is the vertex, we can't have the arrow over there. If it's a line, we can name it in either direction. Doesn't matter what order we put that in. But when it's a ray, we have to be really, really careful for that. Write another name for angle DBC. All right, so let's try to lock in on where DBC lives. Angle D to B to C. So the easy name for that, the easy one there would be, I like less is more for me, I would just call it angle 3. Okay, but the other thing we could call it is also, we could call it angle CBD. That would work as well. So you can either use 3 letters to designate an angle, and the vertex is going to live in the middle of those 3 letters. Or you can just use one number depending on how your diagram is labeled. I think it's easier to use just the one number. Okay, so the next 3 here, I want to cross off these directions, but I want you to try to answer these in the Edpuzzle. We want to classify the angle as right, acute, or obtuse. So let's look at MPR. I'll label it for you. MPR is from here to here to here. Okay, remember that a right angle equals 90 degrees. An acute angle is less than 90 degrees, right? So here is a right angle. Here is an obtuse angle. And here is an acute angle. So let's look at an MPR. Is that right, obtuse, or acute? Let's answer that in the Edpuzzle. So hopefully you looked at MPR and you saw that that's clearly bigger than 90. You have a 90-degree angle that lives in there, so we should call that an obtuse angle. Okay. Let's take a look at RPN. Let's see where RPN is. RPN. What do we think? Is that right, obtuse, or acute? Go ahead and answer that in the Edpuzzle. So hopefully we said that RPN is a right angle. It's equal to 90 degrees. Got that one right. Okay, and then the last one, finally, we have angle NPS. So let's look at it. From N to P to S. Do we think that this is obtuse, right, or acute? Answer that in the Edpuzzle. Okay, so hopefully we said that correctly, is an acute angle. It's clearly going to be less than 90 degrees. So just like with segments, we had congruent segments. That means that two segments are equal. Congruent angles, we have the same thing. It means that their angle measures are equal. So we can say it two ways. We can say angle MPN is congruent to angle NPR. That means the same as saying that the measure of angle MPN is equal to the measure of angle NPR. I know it seems like a subtle difference, but congruency refers to objects being the same, and angle measurement refers to an actual number. So what we're going to be able to do now is look at a little bit of algebra. If we have an angle bisector, then we will be able to say that these two angles are equal to each other, and maybe perhaps solve an algebra equation using that. Okay, so let's take a look and see what situations we have here with our angle bisectors, and we'll try to get some algebra setups here. So in the figure, we have QP and QR. They're opposite rays. So QP, QR, so that makes a straight line. QS bisects angle PQ2. So what I want to do over here is this QS ray, they're telling me that it bisects this angle. So what that means is that it breaks this angle into two equal angles. Okay, they're equal to each other. So I look at this over here to my left, and it says that PQT is 60. That's this angle here, or the whole angle rather, just to be clear on what we're pointing out. From P to Q to T is 60, okay? And then they tell us that PQS is 4x plus 14. So what I need to infer from this, since I have an angle bisector, they told me from the start that I have an angle bisector, I need to infer that each little angle in here are 30 each. This is 30 and this is 30. Okay, and then remember that they're also telling me that PQS is 4x plus 14. So the equation we can establish here is that 4x plus 14 is equal to 30. And then, of course, we're going to just use algebra to solve for x here. So I subtract 14 from both sides, and we would have 4x is equal to 16, and then we divide by 4. So x equals 4 would be an adequate answer for that. Okay, so same situation. We follow the directions up at the top. QS is still a bisector, so we're still believing that these two angles are equal to each other. We can know that that's true. Now we know that PQS is 3x plus 13. Okay, so this is 3x plus 13 in here. That's PQS. And then it says that SQT is 6x minus 2. Okay, so remember, we have an angle bisector here. These two are equal to each other. So the first thing I want you to answer in the Edpuzzle is, what's the first equation that we can set up here? If these two angles are equal to each other, what's the first equation that we ought to be able to write here to start this out? So hopefully you started with the equation that 3x plus 13, one part of that angle that's been bisected, is equal to the other part is equal to 6x minus 2, right? And now, keep in mind, what do they want us to find? They want us to find the measure of angle PQT, okay? So we have to find the measure of angle PQT. Well, I can't find PQT is the whole angle. First thing I have to do is figure out what x is, okay? So do that next. In your Edpuzzle, answer what's the value of x if we solve this equation for x. Go ahead and answer that in the Edpuzzle. Okay, so let's see how we did. Hopefully we subtracted 3x from both sides here. So 13 equals 3x minus 2. And then we add 2 to both sides. So I have 15 equals 3x. And then we can divide both sides by 3. So we should come up with x equals 5. All right. So that's just the first step. They're asking us for PQT. So if x equals 5, remember we could plug into either one of these, okay? And we're going to get part of the angle. They want angle PQT. They want this whole angle here, right? PQT, the whole thing. So if I plug x equals 5 into either one of these, I should get the same thing. Let's see. 6 times 5 minus 2, right? The first piece was we had 6x minus 2, right? So now we know x is 5. So 6 times 5 minus 2 is 28. Let's make sure we get the same thing over here. 3 times 5 plus 13. 15 plus 13 is 28. So we get the same thing either way. But remember what that 28 is. Let's erase a little bit here. 28 is each part of this. This angle here is 28. This angle here is 28. But they're asking us for PQT. So answer in your Ed puzzle here, what would angle PQT be equal to if each of those portions is 28 each? Okay, so hopefully you came up with the measure of angle PQT. So several steps to that we walked through. But the measure of angle PQT, hopefully you said, was 56 degrees. Okay? Okay, so we have some more algebra. Same situation now. Let's look at our diagram and see if we can label what they're telling us. BA and BC are opposite rays. We can sort of visibly see that. And BF bisects CBE. So here's BF, and it tells me that it bisects CBE. So what we can infer from that is that angle 3 is going to be congruent to angle 4. Those two are going to be equal to each other, right? When they tell me that that is a bisector. I want to write that down and keep track of that. Okay, so that's going to be helpful information to us, knowing that angle 3 and angle 4 are congruent to each other. Okay, so let's see what they ask us in the first part. EBF, right? Everybody see EBF? That's angle 3. It's basically angle 3 is EBF. They're telling me that's 6x plus 4. Then they tell me that CBF, which is angle 4, is 7x minus 2. So find the measure of angle EBF. Remember, that's angle 3. They tell us what that is. We know that it's 6x plus 4. So obviously what we're going to have to do here first is solve for x. Okay, so first part of your Ed puzzle here, tell me what the correct equation would be from that setup. If they're telling me that EBF is equal to CBF, what would be the right equation here to get started to solve for x? Okay, so hopefully you chose 6x plus 4 equals 7x minus 2. Okay, so that's step 1. Now step 2, solve for x. Tell me what x equals here. Solve this equation for x and tell me what you get in your Ed puzzle. So hopefully we collected all the x's on one side of this equation. So we would have 4 equals 1x. Going to be easy to solve for now. Add 2 to both sides, and hopefully we came up with x equals 6 for our equation in that Ed puzzle. Okay, so we have x equals 6, but not so fast. Remember, what did they really want here? They wanted EBF. Okay, so step 2 was to solve for x, and now step 3, we're going to figure out what the measure of angle EBF is. So if we know that x is 6 and EBF is 6x plus 4, what's the measure of angle EBF? Go ahead and answer that in your Ed puzzle. So hopefully you just took that value of 6 for x, plugged it in to this equation up here, right? 6 times 6 is 36, plus 4, should have came up with 40 for the measure of angle EBF. Okay, so several layers to some of these. We have to get an equation, get the right equation, solve for x, and then plug back in oftentimes. Okay, so let's look at what we're given in the next situation. We're given angle 3 and angle 4, and we said earlier that these two are equal to each other. So what's the first equation that we can set up? If we know that the measure of angle 3 equals the measure of angle 4, what's the first equation you'll set up? Answer that in the Ed puzzle. So hopefully you said that 4x plus 10 is equal to 5x. Okay? Now we want to find the measure of angle 4. In order to do that, we're going to have to get x first. So solve this equation for x. Tell me what you get for x in your Ed puzzle. So hopefully you just did one step here. Subtract 4x from both sides, and we get 10 equals x right away. And then finally, the last part here is, what's the measure of angle 4? Well, they told us up here. The measure of angle 4 is 5 times x. So we know x is 10. What do we get for the measure of angle 4? Let's answer that in our Edpuzzle. So angle 4 is 5x, so hopefully you plug that in. 5 times 10, and said that the measure of angle 4 is 50 degrees. So here again, they give us angle 3 and angle 4, and we've said from the beginning here that these two are equal to each other. So what's the correct equation to set up to start this? Answer that in the Edpuzzle. So hopefully we started with 6y plus 2 equals 8y minus 14. Now again, first step here is let's solve for y. The only way we'll be able to figure out what CBE is if we solve for y first. So what do we get for y? So a couple of steps, we subtract 6y from both sides, and I have 2 equals 2y minus 14, and then we would add 14 to both sides. This is where we reviewed algebra in the first few weeks of the class. Divide both sides by 2, and we get y equals 8. Now let's be careful here. They're asking us for this whole angle. So if I plug y equals 8 into either one of these equations, I should get the same thing. 6 times 8 plus 2, I get 50. And over here I get 8 times 8 minus 14, I also get 50. Well, that tells me angle 3 and angle 4 are both 50. So what would be the measure of angle CBE? That's what they're asking us for. Okay, what's the measure of angle CBE? And we're going to skip number 6. Okay, we'll leave that one out.